Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for sets. In the previous session we discussed the various concepts related to sets. We discussed complement of a set. We discussed some properties of complementation also. In this session we are going to take some more properties of sets, some more concepts. So let's begin this session. Now friends, let's discuss laws of algebra of sets. Operations on sets such as union and intersection. Union and intersection I have already explained in the previous lecture, and they satisfy various laws of algebra. Okay, the first one is if A is any set, then A union A is A and A intersection A is A. Obviously, see, all the elements of A will be there. This is set A, so and this is also set A. Right, so if at all you have to find out the union, see, all the elements of A are there in A, so A union A will be A and A intersection A will be also A. Now how do you prove that? See, because in exams you'll be asked to write down the steps. So how do you do that? So whenever, as I've already told you, whenever you have to establish rules or you have to show the proof of this sets, what you do is you start with assuming an element. Right, so here I assume an element X. Now X belongs to A. Okay, X is such that X belongs to A or A belongs to A. Obviously, I'm sorry, this is actually X. So X belongs to A or X belongs to A. Okay, so if X belongs to A or X belongs to A, then X belongs to A. Okay, and that is set A. So A union A is A. Okay, so these are the steps that you have to follow. Similarly, A intersection A. Now A intersection A, that means X belongs to A and X belongs to A. Okay, here we are able to see or because it is a sign of union, and here we can see and because that is a sign of intersection. So X, if it is if X belongs to A and simultaneously it should also belong to A, right, then only it will be common between A and A. Okay, so X belongs to A and X belongs to A, that means X belongs to A and that is A. Okay, so that's, you just see, these are like a very simple steps precisely. Okay, and very obvious steps as well. Okay, you just have to write them one or two times, and certain things in the sets, certain laws or certain steps in sets you need to mark up. Okay, because you have to write the proof in this manner only. Okay, in your exams. So be very clear about it. Just write them 2 to 3 times and you'll be able to mark up the things. Now next is identity law. If A is any set and U is the universal set, then A intersection U is A, and let's take all the laws one by one. A intersection U. Now as I told you, you need to assume an element for that belongs to A. So right, X belongs to A. Right, now if A intersection U is there, that means simultaneously, that is and, X should belong to U also. Okay, X belongs to A, and since A intersection U we have to find out, that means X belongs to U also. Okay, that means precisely X is such that X belongs to A. Okay, so that is actually A. So just go for a quick recap. A intersection U means what? A intersection U means X belongs to A and simultaneously X belongs to U also. Okay, so that means X belongs to A, that is for sure. Right, so if X belongs to A, that means this is set A. Okay, so that's pretty simple. Similarly, we can take the second one. Now here we see sign of union, so we'll use OR. Okay, so X belongs to A or X belongs to phi. that means that is A union phi. Okay, so precisely X belongs to A. Okay, because X belongs to A or X belongs to phi. Now phi is a null set, that means X definitely belongs to A. So X such that X belongs to A, and if X belongs to A, that means it is set A. Okay, so if it is intersection sign, use AND. If it is union sign, use OR. Okay, nothing is difficult. I just solved the third one also. Now see, A intersection phi. So X such that X is element of A and X is element of phi, right? Now phi is what? A null set, right? So X, if it is an element of X belongs to A and X belongs to null set, that means actually what? It is a null set. Nothing is common between A and null set. So precisely it is X belongs to null set, that means it is a null set. Getting my point? If it is a null set and if it is A, so nothing can be common between a set and a null set. Okay, so that will always be a null set. So here it is AND, so we are it is intersection sign, so we are using AND. Similarly A union U. So X such that X belongs to A, and for this union we'll use OR X belongs to U. Okay, so X belongs to A or X belongs to U, that means X obviously belongs to U, that means it is actually U. Okay, because between A and U, U is the superset. Okay, so this is how we can establish the proof of all these three laws. Now next is commutative laws. A and B are two sets, then union, intersection and symmetric difference of sets A and B are commutative. That means order doesn't matter. A union B will be equal to B union A. So first of all, let's take A union B is equal to B union A. Again we'll start with the assumed element that is part of that belongs to A. Okay, so A union B. What is A union B? Suppose I take X as an assumed element. Now X, if X belongs to A union B, that means what? X belongs to A or X belongs to B. Okay, X is an element of set A or X is an element of set B. Right, then only X will be element of A union B, right? Union, so it is OR. Okay, so X belongs to A or X belongs to B. Okay, so precisely, so we can reverse this sentence also. X belongs to A or X belongs to B, that means X belongs to B or X belongs to A, that means X belongs to B union A. Okay, that means A union B, we started with A union B. A union B is subset of B union A. Okay, so that is the first thing. Similarly, X belongs to B union A. X belongs to B union A. That means X belongs to B or X belongs to A. That means X belongs to A or X belongs to B. Right? We just reverse the order. That means X belongs to A union B. That means B union A is subset of A union B. Okay? So both of them are subset of each other, right? A union B is subset of B union A and B union A is subset of A union B. That means it is possible only when both the sets are equal. Then only one set can be subset of other, right? The one set is subset of other, that is set X is subset of set Y and set Y is subset of set X. It is possible only when X is equal to Y, right? So here A union B is subset of B union A and B union B A is subset of A union B. That means set A is equal to, A union B is equal to B union A. Okay, so that is the first law we have established. Similarly, we can take the second one, A intersection B is equal to B intersection A. So I take X, and X is element of A intersection B. That means X has to be element of A and okay, then only X will be element of A intersection B, right? This is the portion that is common. So that is A intersection B if it is A and it is B, right? So X has to be element of A and B both as well. So X is element of A and X is element of B. That means X belongs to A and X belongs to B. So we can reverse the order. X belongs to B and X belongs to A. That means X belongs to B intersection A, right? So if X belongs to B intersection A and X belongs to A intersection B and X belongs to B intersection A, that means A intersection B is subset of B intersection A, right? A intersection B is subset of B intersection A. Similarly, we can take next is B intersection A. X belongs to B intersection A. Okay, now if X belongs to B intersection A, X belongs to A and B and X belongs to A. If X belongs to B and X belongs to A, then similarly X, we just reverse the order, X belongs to A and X belongs to B. That means X belongs to A intersection B. That means A intersection B, B intersection A is subset of A intersection B. B intersection A is subset of A intersection B. Now A intersection B is subset of B intersection A and B intersection A is subset of A intersection B. So again both of them are subset of each other, so that is possible only when they are equal. Okay, so that's pretty simple. You just practice the steps, right? How to write the steps, that is it, nothing else. Not at all going to be difficult. In the very same manner we can prove A delta B is equal to B delta A. Okay, so next let's take associative laws. Now let's take the first one. If ABC are three sets, then the union and intersection of these sets are associative, right? Now what associativity is? A union B, it is in bracket, and union C will be equal to A union, that is B union C is in bracket, right? So we have to establish the associativity over here for the union of sets. So what is the first step? You assume one arbitrary element X be an arbitrary element of A union B union C, right? Now if X is an arbitrary element of A union B, that means X belongs to either A or B or X belongs to C, right? A union B, that means X belongs to A or X belongs to B, and then for this union sign I am putting one more or, then X belongs to C, right? So X belongs to A or B, either I write X belongs to B. So X belongs to A or X belongs to B, bracket, and or X belongs to C. Okay, now we can change the order because it's or sign everywhere. So what I can do is X belongs to A or X belongs to B or X belongs to C, right? Now this means X belongs to B union C. Okay, so X belongs to A or X belongs to B union C. That means X belongs to A. For this I am just putting union sign, and B union C, right? That means X belongs to A union bracket in bracket B union C. So what we can say, that's A union B union C is subset of A union B union C, right? This is subset of this. Okay, now similarly we can prove the vice versa, that is A union B union C is subset of this, and I have already told you, if one this is subset of this and this is subset of this, so both of them will be equal. Okay, so this is how you can prove the associativity in the case of a union of the sets. Now again, for A intersection B intersection C, we'll start with X. X is an arbitrary element. Now we have intersection sign over here. That means A should be part of, X should be part of A as well as B intersection C. That means X should belong to A, B and C, all of them precisely, right? So we start with X belongs to A and I just put up a bracket, X belongs to B and X belongs to C. Right? Now we can change the order. X belongs to A and X belongs to B and X belongs to C. That means X belongs to A and X belongs to B. That means X belongs to A intersection B and X belongs to C. That means X belongs, or we can say X belongs to A intersection B, and for this again I put intersection sign C, right? That means we started with this and we are getting this. That means X belong to A intersection in bracket B union C and X belongs to A intersection B in bracket intersection C. That means this is subset of this, right? A intersection B intersection C is subset of A intersection B intersection C. Right? Similarly, the other side can also be proved. In that case, we will be getting this is subset of this. As of now, we are getting this is subset of this, and while we start with this, we'll get this is subset of this. So if this is subset of this and this is subset of this, that means both of them are equal. Okay, so that's very simple, and I'm sure you are getting it. Just write it 1 or 2 times, you'll be able to get it. Okay. Next is distributive laws. If A, B and C are any 3 sets, then the union and intersection are distributive over intersection and union respectively. That means A union B intersection C is equal to A union B intersection A union C. We have to establish this. Okay, again we'll start with X. Let X be an arbitrary element. Now we convert this to language. A union B intersection C. So X is element, X belongs to A union B intersection C, right? That means X belongs to A, and for this a union sign I'll put OR. X belongs to A or X belongs to B and X belongs to C. Why? Because it is B intersection C. So intersection is converted to AND. Okay, so X belongs to A, or for this union sign I am putting OR, X belong to B and X belong to C, right? Now what I do, X belong to A or X belong to B and X belongs to A and X belong to C. Okay, X belong to A or X belong to B and X belong to A or X belong to C, right? Just taking this with this and this with this. Now X belong to A or X belong to B. That means X belongs to A union B, right? Or means union. So X belongs to A union B and X belongs to A union C. Right? Now this is AND sign over here, so this can be converted to intersection sign. So that means X belong to A union B intersection A union C. Right? That means X belongs to A union B intersection A union C. That means this is subset of this. That means A union B intersection C is subset of this. Okay. Similarly, we can start with this and we can end with this. So once again, this is subset of this and this is subset of this. So both of them will be equal. The same strategy we are following for last 3 laws. Okay, so that's very simple. You have to start with an arbitrary element, just replace the union signs by or and intersection sign by and. The first one has to be proved the subset of the second one, and then second one has to be proved the subset of the first one, right? So both of them are subset of each other. That means both of them are equal to each other. Okay, so this is how you can establish the distributive law also. Okay, similarly we can see this. Now see this, A intersection B union C. Again we start with X, so X belongs to A, and for this I'll put and. I put a bracket. X belong to B. For union I'll put or. X belongs to C, and this is in bracket, right? For intersection I put and bracket. X belong to B or X belongs to C, right? Now what I do is I take one by one. X belongs to A and X belongs to B, or X belongs to A and X belongs to C, right? Now X belongs to A and X belongs to E. That means X belongs to A intersection B, right? And or X belongs to A and C, so X belongs to A intersection C. Now I replace this or by union sign. That means X belongs to A intersection B union A intersection C, right? So I started with X belongs to A intersection B union C, and I'm getting X belongs to A union B intersection B union A intersection C. That means this is subset of this. Okay, if this is subset of this, similarly we can prove this is subset of this. Again, both of them are subset of each other, so both of them will be equal. Okay, so that's very simple. I hope you are getting it. You just have to write it 1 or 2 times, and you have to start always with X as an arbitrary element. Okay, for intersection sign you just put and, for union sign you just put or. Okay, apart from that there is no difficulty. Open up the bracket and rearrange the things and just get the right hand side and prove that the left hand side is subset of right hand side. Again, right hand side is subset of left hand side, so both the sides are subset of each other, hence they are equal, right? So it's very, very simple, right? If in exams it is asked, you can write it in just 1 or 2 minutes. Okay, so friends, in the next session we'll be taking De Morgan's laws, and do revise this session and the previous ones. I'll see you in the next session once again. Bye bye.